Now we're going to continue with probability and start looking at independent versus dependent events. So to begin, we will look at independent. So when two events occur and the first event does not affect the probability of the second event, those events are independent. The key thing to keep in mind here is when two events, so we're doing two separate things, and the first one has nothing to do with the second one, or it does not affect the second one at all. A key part is if you see with replacement, you know that's got to be independent, because whatever I'm taking out, I'm putting it back in before I draw the second time. Okay, and our rule is that the probability of A and B is the probability of A times the probability of B. So if they're independent, you just multiply the two probabilities. So for some of our examples, first, we have a fair six-sided die rolled 2 times. I want to know the probability that it will land on a 4 each time. Well, when I roll a die, I roll it the first time, I pick it up, I roll it again. Neither of those affect the other. So the probability that I get it the first time, well, a 4 is 1 out of 6. And the second time is a 1 out of 6. So I multiply. So the probability of getting it 2 times in a row is 1 out of 36. Our second one, Meg flips a coin 3 times. I want to know the probability that she will get heads both times. So she's flipping it 3 times. Again, she's picking up the same coin and flipping it again. So she's starting fresh every time. Nothing affects anything. So the probability she gets ahead the first time is 1 out of 2. A second time, 1 out of 2. And a third time is 1 out of 2. So we multiply, and we just multiply straight across. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So 1 out of 8 that she gets it 3 times. Ava is taking a multiple choice quiz for which she has not studied. Sounds kind of familiar. There are 5 questions on the quiz, and each question has 4 possible choices, so it's a multiple choice quiz. If Ava guesses on each question, what's the probability she will receive a perfect score? Well, for the first question, if she is just guessing that only one right answer means 1 out of 4. Right? On the second one, has nothing to do with what the first one is, so we get 1 out of 4. And we're going to do this for the 5 questions. So 1 out of 4, 1 out of 4, and 1 out of 4. Just multiply. Okay, they don't affect each other, so it's all independent. And multiply straight across. 1 times 1 times 1 times 1 times 1 is 1. And then 4 times 4 times 4 times 4 times 4 is 1024. So she's got a 1 in 1024 chance of getting 100 on this quiz, which is why you need to study. And then just to give a little more perspective on that, that is super close to 0%, right? It's like 0.00097 and so on, right? So that's not likely at all that she's going to get 100, which means you need to study for your math quizzes. All right, for the third or fourth one, Jack consistently makes 80% of his free throws. We want to know the probability that he will miss 2 in a row. Right, so it's kind of tricky. The probability that he makes it is 80%. The probability that he misses it is the complement, so they have to add up to 100, so that's 20%. So we have 20%, which we're going to write as a decimal, is 0.2. Right, so we've got 0.2 for the first one that he misses, and then again, he might miss the second one, so that's 0.2. And 0.2 times 0.2 gives us 0.04. Right, so that's my probability, which we can write as a percent as 4%. Right, make sure whenever you're doing these with percentages that you change them to decimals first, and then you can rewrite it as a percent if you need to. Okay, and then our last one, the weather forecast predicts a 40% chance of rain on Saturday and a 70% chance on Sunday. We want to know the probability that it will rain on Saturday and Sunday. So again, I'm going to change them to decimals, so 40% is 0.4, 70% is 0.7. Okay, they don't affect each other, so we've got 0.4 times 0.7, which is going to give us 0.28. And that, as a percent, is 28%. So there's a 20% chance it's going to rain on both days. Then I want to know the probability that it will not rain on Sunday and Saturday. So not raining on Saturday and not raining on Sunday. So that means not Saturday and not on Sunday. Alright, so the probability that it does not rain on Saturday would be the complement of 40%, which is 60%, so that's 0.6 as a decimal, times not Sunday, which is the complement of 70 or 30%, and that's 0.3. So then we multiply that, we get 0.18, which becomes 18%. So there's an 18% chance it's not going to rain on Saturday and Sunday. For this last one, why don't these two probabilities add up to 1 or 100%? I want you to kind of think about this. We'll talk more about it in class, but remember, a probability and its complement are supposed to add up to 1, right? Because either it's the probability of that or that's not happening, which is everything else. Right, so think about why maybe raining on Saturday and Sunday and not raining on Saturday and Sunday could not be complements, not necessarily an add up to 1. Right, but again, we'll talk about that in class. Dependent events is when two events occur and the first event does affect the probability of the second event. Right? A key part of this is when you see without replacement. So now I'm drawing a card and not putting it back in the deck. So this is without replacement. So drawing that first card changes the probability of drawing a second one when there's one less card in the deck. So whenever we have dependent events, we have the probability of A and B happening at the same time or in the same round. Is the probability of the first event, right? That's the same as we just did. Nothing changes about that. Times the probability of B, and then we have this bar. So this bar means given. So we have the probability of the first event times the probability of the second, given that the first one has already happened. So we're going to change the probability a little bit. So some of our examples. First, we have two cards drawn randomly from a deck without replacement. So that means I'm drawing a card and then I'm leaving it out and drawing a second card. I have another probability that we draw two aces. Well, I'm going to take the probability of the first one times the probability of the second one, given that the first one already happened. So the probability of the first is drawing one ace out of the deck of cards. Well, I have 4 aces to choose from and 52 cards to choose from. So the probability that I get an ace is 4 out of 52. Then I'm going to multiply that with the probability of the second one, given that the first one's already happened. So we're assuming that we've already drawn an ace and set it aside. That changes my probability because now instead of 52 cards, I only have 51 cards to choose from. And instead of 4 aces, I've already taken one ace out, so I only have 3 aces to choose from. Right? And then we just multiply straight across. So 4 times 3 is 12. And 51 times 52 is 2,652. Right? And then we need to simplify that. Always simplify your fractions. And we're going to get 1 out of 221. So you have 1 in 221 chances to get 2 aces in a row. 20 students enter a contest, 5 from Hoggard, 4 from Hanover, 6 from Ashley, and 5 from Laney. If the winners are chosen randomly, what is the probability that a Hoggard student will get first, second, and third place? So again, now we have 3 events, so we're going to be multiplying 3 different things. And so we're going to start with the first one. So the first person being Hoggard. Well, we have 5 Hoggard people to choose from. And we have 20 students total. So that's 5 out of 20 for the first one. Then I'm going to multiply it by the second time. But now that first one's already been chosen, they can't win all 3. So I only have 19 people left to choose from. And we already won, a Hoggard student already won, so that leaves 4 Hoggard students for the second place. Then for the third one, now there's already been 2 students out of 1, so that leaves us with 18 students, and only 3 Hoggard students are left. And then we're just going to multiply straight across. So 5 times 4 times 3 gives us 60. Right? Then 20 times 19 times 18 gives us 6,840. And then we want to simplify. So we do 60 divided by 6,840. And that gets us to 1 over 114. Right, so that's not the best odds of getting all 3 Hoggards as first, second, and third. Right, for the third one, we've got a jar containing 8 green marbles, 4 blue marbles, 3 red marbles, and 5 yellow marbles is on Miss Ottaway's desk. A marble is chosen at random, not replaced. That's the key part. Not replaced. That tells me that these are dependent events. And then another marble is chosen. So I've got a couple of probabilities we want to find. So the first one is that a red marble is chosen, then a green marble. So we choose a red one, we set it aside, and then we draw a green one. All right, so getting a red one, we've got 3 red marbles total over, let's see, 8, 4 is 12, 3 is 15, 5 is 20. So we got 20 marbles altogether. So that's 3 out of 20 for the first red marble. And then I leave that red marble out. So now instead of 20 marbles, I've got 19. But I still got all green marbles in there, so that's 8 out of 19, because I took a red one out. and then we multiply. So we get 24 over 380. And then when we simplify, we get 6 over 95. Okay, 2 blue marbles. So the first one's a blue, so that's 4 blue out of the 20 total. But then I take a blue one out, so I only have 3 blues left out of 19 total marbles. We multiply to get 12 over, 380, not 200. So 12 divided by 380, and we want to simplify the fraction, and we get 3 over 95. That's a bad 3. A red marble, then a yellow marble. So that red marble is the same as the first one. We have 3 marbles out of 20 to choose from. But then we only have 19 marbles left and our 5 yellows. So that gives us 15 over 380. Which is 3 over 76. 2 yellow marbles, so we start with 5 out of 20. And then I take 1 yellow marble out, so that's 1 less total marble and 1 less yellow marble. So we get 20 out of 380, which is going to simplify to 5 out of 95, which we can go 1 farther. And get 1 out of 19. And then for the last one, 2 purple marbles. There are no purple marbles, so the probability we get 2 of them is 0 because we can't even get 1 of them. Right? So independent and dependent events take place when you have 2 separate events happening. Right? So you're doing something 2 times in a row. If the second one has nothing to do with what happened the first time around, doesn't depend on it all, it's going to be independent. So flipping a coin, rolling a die, drawing a card and putting it back in there with replacement. And then if the second event does depend on it, so if it's changed by what happens the first time, where you draw a card and leave it out, right, that's going to be dependent events, and it's going to change slightly. But regardless, you're still multiplying. So independent and dependent, we multiply our probabilities, just dependent, the second one changes a little bit. Okay, 2 separate events, independent and dependent.